Hi everyone, welcome. Thank you so much for joining us. I'm really excited about this stream today because today is one of the days I get to show off like all of the state machine things I've been learning over the past months, and finally I just like feel like it's time to actually start to do some sort of education around like state machines, building UI components because I've worked with this for a few months now, and I really think that this is the proper way to build components, and maybe not just to build components, to model any complex logic. So I'm really excited. I have Farzad here from Stately Studio, Stately AI here with me. Farzad, do you want to say some intro?
Sure. Yeah. So, hey everyone, really glad to be here. Thanks, Sage, for having me. I'm Farzad, and I work as an engineer in the State AI team, closely with David, if you know him, the prophet of state machines in the JavaScript community.
Yeah, that's awesome.
Yeah. And Sage, I just wanted to say that like your intro of state machines are sort of like the proper way of building UI components, from like the naive ones and basic ones to up to the complex ones. It's really I really appreciate to hear it from you, having built, Chakra UI, Zag.js, and now ArcUI, and then Panda CSS. You've done a lot, and hearing this from you is actually a really, really great thing.
Yeah, for sure. I mean, to be honest, I don't think that I can ever go back to the days of like creating custom hooks and doing use effect and use reducer and stuff like that. Because I really think that, I mean, as much as this makes you feel like you're a developer, you're writing some React code. I mean, I think that like taking that top down approach to actually thinking like an engineer and architecting a solution. You don't feel. I mean, you don't want to feel like a plumber. You just putting the duct tape in there with some if condition in the use effect, so it doesn't run too much. I think I've faced that way too often, and I think the number of edge cases keeps on sort of expanding and growing as the number of features for any given component. So
That's
that is a
true. Yeah.
pain. Yeah.
Yeah. It's one of the favorite aspects of building UI is, for me, is like most people don't realize how UI development can be so complicated and complex. My favorite like example is usually what I talk about is, like UI components usually scale linearly to the requirements, but like you add like default value to an input, then unchanged, then you change to committed on Blair, and blah 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 blah. Everything is great as long as you're working in the platform and in the framework that's the API is built around that component, until one day somebody asks for a feature or a constraint that just completely blows away your whole architecture. And now
Exactly.
you wish you started with a state chart in the beginning. If you could just move a bunch of building blocks around, and your logic would have worked. But without the state chart, oh man, yeah, good luck.
Yeah, good luck. I mean, I think that this is especially true for like open source component libraries, where like in my mind, I'm starting to think now that if I wanted to build a design system for a company, so we've got a company and a product, I feel like it's a lot more easier because like your company has a specific use case of why you need that component. So like modeling that, maybe I could still rethink using React hooks and sort of like creating a custom hook, but in an open source world where like there's like different requirements, different features that people want. People say, please add a flag for this new feature so that when I try it, it just works this new way. And then when you do that, the other person says, oh no, you just broke my component because of this new flag. And then it goes like, it just goes bonkers from there. And it's like, it's pretty hard to navigate navigate those kind of things without actually a state chart in there to help manage the complexity.
Very well said. Yeah, if you know the constraints of the problem you're solving upfront, like an in-house design system that's a scope to the requirements of a single business, it's not that hard of a problem to solve. But as you said, open source is deferring those requirements to all the consumers out there. So it's very impractical to have unit tests or any other source of testing based on all those requirements reported over the course of a few years in GitHub
Yeah,
issues. Yeah, and honestly, like if anybody here have worked on a larger scale complex code base, you just you have a limited capacity for remembering things. And
sure,
even if you were the only person working on this for a few weeks, then there's a limited frame and window that you can carry around with you, and
totally,
anything outside that frame is just gone, and you have to rethink and refigure out. Yeah.
totally. Totally awesome. So I just wanted to put it out there that this would be like a series of live streams. So it's not this is not a single live stream to solve all the problems and ship to npm. So it's mostly just like a quick one step at a time type of live stream to actually get people get you all to feel a bit more comfortable seeing state charts and using state charts, hopping onto Stately Studio and trying to model some sort of logic for your components when you need them in your company. Because one thing I've come to realize is your component library, whether open source or not, will not give you all the features you need at any point in time. You might have to build some sort of complex logic for specific parts of your application, and you have to build those things yourself. So we're just trying to sort of like break this into chunks of consumable content. And today we are going to try to narrow down on ideally, I'll technically call this a floating panel, but I mean, for the sake of this, we just call it a resizable, I think, or a draggable panel, I guess.
Rest in peace,
Anyway, you call
jQuery Draggable.
it.
If you remember
Yeah.
jQuery Draggable Windows.
Yeah, exactly. So we want to actually like take a top-down approach to see how far we can go in this stream. Maybe we need another stream. We'll see at the end of this. But we actually want to start by thinking through this type of component, showing you an example of what that looks like, breaking it down to different anatomy pieces and how the usage is going to look like. So I always believe that when you want to build anything, you start with the end in mind. So you have to like go from that end and then come back to actually like engineer it to the present. So we're gonna start that right away. All right.
So yeah, I'm just thinking. Yeah, I think the best way would be to just jump into the Stately Studio and see how much of the interactions around resizability and draggability of this component we can model. And then before jumping into the code and getting our hands dirty, maybe we can try to model as much as we can.
Oh yeah, for sure. So I generally like do some sort of design first, or I say Figma first
True.
approach, which is just like I'm just gonna do all the rough sketch in Figma before actually going too deep into like code or technical bits, so everyone
Yeah,
can actually relate. So
that's
I'll
a great
start by
idea.
just sharing. I'll just share my screen very quickly. Uh, okay, so right here we're in Figma. I think I sent you the link to this. Was that if you maybe check your
Yeah.
messages?
Let me.
Yeah.
Yeah. You carry on. I'll catch up.
All right, sounds good. I mean, I'm just a huge fan of Figma. Maybe Excalibur will probably be better, but here we've got like some sort of panel. It's very boring. It's just a rectangle. But then there are a couple of things we want to be able to do with this panel. So if you take a look at the Figma panel, like any draggable panel in a tool like Figma today, a couple of things you will notice is the first thing here is that there's some sort of button to actually activate the panel. And then there's some sort of button to close the panel. So that is like I'd say the easiest thing we can do today, which would be like, let's assume that we've got some sort of like button to actually trigger this panel. Let's just call this like open panel, super small font. We can just bump it up. So, we've got this button that actually opens the panel. And then on one side of the panel, we've got some sort of X. I'm just going to use text because I mean, I'm not in my design mode right now to get into icons. So
That gets the
here,
job done.
yeah, so we just go just like the panel title. And then at some point in here, we've got like some sort of resizable element. So we could maybe just like put it somewhere at the bottom. So when you actually interact with that guy, it becomes a resizable element. So maybe the stroke is a bit too much. I'll just get rid of the stroke. So this would be a resizable undo to actually like technically resize this panel. And then at the top here, we would put like some sort of like draggable handle. So I mean, we can start something. We can start as simple as just putting something here to say, hey, if you drag this item, it actually just it's just gonna move the panel around. So put that as a different color here. And then we have some sort of like basic idea around this. So to make this actually feel a lot more complete, again, it's just my classic process when I'm trying to imagine a component. I'd come here and say, okay, so we've got a couple of parts here. I would call this one the trigger. So this is the I'll call this like the trigger, the thing that actually like triggers the panel. Um, I'll call this entire thing some sort of like content. So that sort of like goes. This whole thing here becomes the content, and then this one here would be maybe we can call this the drag handle.
Yeah.
So the reason I tend to always like use this kind of names is so we actually have the same language when we are referring to like component parts. And I don't say something that feels weird and you'll be like, oh, what are you referring to? Are you referring to the title or the button? And it's like, it just helps us have a shared language. So yeah, I'll call
Mhm.
this some sort of like close. I mean, you could also call it close button or close trigger.
Yeah, because it could be
Um,
closed in different ways. Yeah.
yeah, exactly. And then here, you'd call this one, let's just call this the resize handle. Um, and there you go. So just generally speaking, we've got like a quick breakdown of like all the key things that we need here. Now, one thing that I sent to Fazal before we started, uh, I think like I was really tempted to send him some sort of guides to actually like help him prepare a bit more. But I said no, I'm just gonna just like wing it here and show you guys. So we want to add a bit more extra features to this. And see how far we can go. Again, no promises. We just want to try to make it as practical as possible.
Oh, this is not a live coding session. We're not being interviewed, so this is fine.
Yeah. So the interesting some interesting features I'd love to include is the idea of a dockable region on a page. So what I mean by this is if you drag the panel all the way to this region on the page, something's gonna happen at least, right? So at the very least, we'll probably assume that the panel would expand to fill the width and height of that region.
So it's basically like the window manager on macOS or something where you drag something, like you freely resize and drag a window until you put it in like a drop zone that expands to that, like a part of the
Exactly.
screen or something.
Exactly.
Yeah.
So if you as you drag along all the way to this region, you see some sort of like highlight to tell you that here you're close to the dockable region, and if you drop it or if you stop your drag in that region, it just like scales the width and height and stuff and puts it there. Again, I
Mm.
mean, we just try to see how far we can go, but I mean, I think this is a pretty solid, practical, resizable component. I think.
Yeah. Yeah. This can get pretty challenging in terms of implementation in DOM. Um, but what's great about like modeling with the state machines is you always take a step back and try to think about like events through which you interact with the component. Um, so what I mean by events here is that like you don't really care in terms of how these events are being sent or communicated between the UI, which is in the DOM,
Mhm.
and your actual component, which is your abstraction. Like
Yeah,
for example, if you want the panel to be opened, you might be thinking that yeah, I click on the open panel and that the panel pops out, and you might be tempted to like model it with that perspective, meaning that model it around the implementation of clicking on a button and then something is shown in the DOM. Whereas with the state machines, all you care about is this whole state machine that is driving the logic of this panel receives an open event. It doesn't care where this open event is originated from, whether
mm,
this is a button or any other button, or even the user, I don't know, like in other window did something that broadcast channel has brought to this window, whatever. I mean, just go nuts.
yep,
Anything that could trigger that event might open this. And like the same is for closing, right? Like you could click on the close trigger button on top right. You could probably press escape. You could click on the
yep,
overlay, different ways. So as long as the state machine, it just cares about, like, the event that you receive. So if you want to try to model the
Awesome.
whole logic here using state machines, we need to think about events first. So I think
Awesome.
that's the step one we want to do.
All right. So
Maybe I
let's
can,
yeah, let's
yeah,
jump into the step one. Yeah, feel free to share your screen. I'll just switch to your screen now.
sure, yeah. Let me try to figure out how to share my screen. Maybe my entire screen. Hopefully things don't go crazy. Um, all right, do you see my screen here?
Yes.
All right, great. So I just created a dummy project named P1 in Stately Studio. Basically, if you want to try Stately Studio, the easiest way would be to go to state.new, a very fancy domain that we bought for people to just get very, very productive, like docs.view, slides.view that Google had, things like that.
Yeah, so
Um,
nice.
yeah, the idea of a Stately Studio is basically it's a platform that eventually will help you build products end to end. And it doesn't matter whether you're a developer coming from a development background, or a product manager, or a product owner, or a designer. As long as things are modeled using diagrams and boxes and arrows, every human being, absolutely everybody, should be able to interpret the logic and understand it. And there are different ways of communicating. One of them is through these diagrams. So that's the gist of Stately Studio. But the team behind the Stately Studio, at least part of the team, has been active working on the open source version, which is the engine that um, drives the whole logic, like in the background of this whole
Yeah.
platform, called based on a open source library called XState. Not XState Viz, the XState itself.
Yeah.
So XState is the implementation of state charts based on a standard called SCXML in JavaScript that's been around for 5 to 6 years, give or take. And version 5, which the whole community is really hyped about, is coming in a week or two.
Yeah.
I'm not promising any dates, but I think the deadline is early December, something like that.
Awesome.
Anyway, let's start very fresh here. There is a lot of things here that might feel intimidating at first when you get started with the Stately Studio, but for the sake of just focusing on one thing, we probably want to hide the whole UI and go into the Zen mode. Just look at the canvas and start modeling.
Nice.
So let's call this. What do we want to call this, Sage? Draggable, resizable, maybe Patrick. Any name.
Yeah, let's just call this a panel for now. Just a simple word,
Yeah.
panel. That's it.
Okay.
Yep.
So our panel is going to start by having different events. The panel can not only do you have to think about events, but also you eventually have to think about the states. So that's a state machine, states and events, and potentially effects in future. But let's say that we have a panel that's closed. All right. So let's add a child state named this is closed. I'm going to say that the panel is in a closed state. And if I receive an open panel event, then I'm going to transition or change the state to open. Very basic, very primitive. And then when I'm in the open state, if I receive a closed event, I don't know my way around my trackpad. So bear with me, please.
Yeah, there is.
Yeah, let me just do that through the mouse. Yeah. So if I receive a closed state, come on, English. If I receive a closed state when I'm open, then I will transition back to the closed state. And the way that this is represented in the DOM is if you're in the closed state, you have display none or visibility hidden or something. And then when you're in the open state, you actually show the DOM content. All right. So let's also, again, think about the design that Sage had. Let's think about resizability, draggability, and all that. When you click on, like initially, this indicator here means that we are initially starting from the closed state. So the panel is closed. Then you click on the button, and we send open panel state to event to the state machine. It transitions to open. Now the panel is open. And then if you click on that cross button on the top right, it says the close. Let's call this closed panel to have consistent naming. And then it gets back to closed state. So far, so good. We have that part modeled. What else do we want to model from here?
Okay, so
Um,
let's see. Maybe we can start with the like dragon, I guess.
Dragging.
Yeah.
Okay. So when somebody talks about dragging, I immediately, like, I'm an old school person, and I think about draggable element in jQuery UI. It was a great project first time.
Yeah.
Um, so draggable elements in jQuery, they could be dragged like in anywhere, basically in the client rect of the component that you basically pressed and moved.
Mhm.
But we have a limited like header part that is just responsible for that. The way that dragging works in web is you have different pointer events. You can, of course, model this around mouse events, but that will only work with the external mouse and probably trackpads.
Correct.
But it won't work with the touch events on like touch devices. So pointer events are the consistent events that work regardless of the device. Um, so when you are open, we definitely want to model the whole dragging interaction when you're open, because the closed panel cannot be dragged, of course. Or
Yeah.
maybe it could. We don't know. But for now, we could just assume that when it's open, it could be dragged around. And then later on in the DOM implementation, we'll see that like we can limit it to part of the component.
Okay.
Like, yeah. Um, so in terms of draggability, we need to add some child states. So child states are a concept in the state charts that help you model part of the interaction or behavior only if you're inside another state, meaning that
Mm.
dragging is only possible if you're already open, like close the state. So you don't have to take care of cleanup and cleaning up event listeners and stuff like that. If you model them with the primitives in the state machine, they will already be taken care of.
Mm.
So in terms of dragging, now we're focusing on that problem. Initially, I'm not even dragging or anything. Let's call it idle. So I'm idle, and then I press on the component, and that is the pointer down event, right?
Punch it down.
So
Yes.
so when I receive the pointer down event from DOM, that means I'm probably in like a state called pre-dragging or something.
Mhm.
Where you probably want to change the style in CSS, show a cursor that's grabbed or something like that. Maybe you can also call it grabbed or something.
Yeah.
That's basically where you have your mouse pinned on a place on the element, but you haven't still dragged. The moment you start sending pointer move event, that's where the dragging starts.
Mm.
Um, so yeah, so let's have another state called dragging, and it's initiated from pre-dragging if you have pointer move. Maybe pre-dragging was a little bit of over engineering. Maybe we didn't need that, but we
Yeah. I
could
mean,
probably say.
we could
I mean,
probably just
let's.
do with just dragon, I guess. Yeah. But
Uh,
I mean, I think you're right. Let's just move on.
yeah, I mean, let's just have it very
Yeah.
simple.
Mhm.
So when you're dragging, if you how do you get back to idle when you stop, right? And with the way that you stop, like DOM is weird in terms of these events. Things
Sure.
go wrong in a million ways, and that's why you have like a million events that could stop this. From my experience, there are three events that you need to handle here. There's pointer up, which is
Yeah.
of course when you unpress, stop pressing. There is pointer leave, and I think that's when your pointer leaves the window or something like that. And then there is pointer cancel.
Yeah.
Uh, yeah, these are like, I mean, the definition, the technicalities are up on MDN, or you can read the spec, but these are basically the three classic events that you need to handle when you're dealing with dragging. Any of these could happen, and you will transition back to the idle state. Now, when you're dragging, it's not enough to just think about states and events. We actually need to execute side effects to remember the position.
Mm.
I'm thinking maybe like are we missing any events or states here before we move to the effects part where we take care of the width and position and stuff like that. So I'm idle. I click on something. I go to pre-dragging. I start moving. Oh, okay, yeah. Actually, if I have any of them here, basically it
Yeah.
doesn't matter where I am, because if you're in pre-dragging where you're pressed and you haven't moved yet, and you receive pointer up, pointer leave, or pointer cancel, you still have to go back to idle.
You
So it
have to go
doesn't
back to.
matter where you are, anywhere you are, in any state, you receive any of these three events, you need to go back to idle. So maybe we need to connect them to the root. It basically means as long as the popover or the panel is open, if you receive any of these three events, it doesn't matter where you are. You actually have to go back to idle and reset. Let me just auto layout. Oh yeah, that's
No.
I think that's a new feature that they've released today that improves partial auto layout. Yeah, so it's nice. Okay, so it's a little bit more clear now. Pointer cancel, pointer up, and pointer leave will take you to idle wherever you are. Pointer down, pre-dragging, pointer move, dragging. Great. Okay. While you're dragging, you keep sending pointer move to yourself. So it's going to be something called a
Pointer move.
actually let me
Self event. Yeah.
exactly self
Self
transition.
transition.
Yeah,
Hmm.
because otherwise you will receive the first pointer move event and then you will ignore the rest. So you keep doing that, and then anyway you have pointer cancel and you go back to idle. Okay, everything is great so far. Now, while we're dragging, we need to keep track of the position of that element that we're dragging, so that we are able to diff the position at the end and then
Yeah.
move the element. Yeah. So when we are here, that's like for remembering things or data in the world of state machines, we have something called extended state or context. We call that context. Let me enable the UI again so we can actually see where we define the context of the machine. So context is basically, if you want to think about it simply, it's just an object, like a JSON object. I think we want to add something called, let's call it position, which initially is 0, 0 or something like that. And it's just, let's automatically infer it and add it to the schema as well. So it's an array. And you want to have it as a tuple of X and Y. And we want to remember it while we deal with pointer move events. So help me out here, Sage. While dragging, what effects needs to be actually executed? Like you're familiar with state machine yourself. You model the whole component library Zag around this.
Yeah, I mean, so I've got like one naive question before we move on from here.
Sure.
So I mean, as a React developer, when I hear the word context, like I mean, I have a different frame of mind, because I'm like, what do you mean by context? Do you mean like React context, or like you're doing some React context thing under the hood? Like, I mean, what is that? Is that the same thing, or is this something different?
They're different. So one thing to note here is like state machines are a concept that are agnostic from the technology you're using them in. So it doesn't matter you're using React or Vue or Svelte. It doesn't even matter that you're using JavaScript, TypeScript, any other language, basically. In the old days of electronics, when people were dealing with transistors and like the bulbs and everything, and modeling everything in a binary way, like physically, literally binary way, state machines were present as a concept, like turned on, turned off. So this whole concept is completely agnostic from React or any other library or even your programming language. So when I say context from now on in this series, I mean the data that the state machine remembers. Basically, think of it as just an object. So think of this. I didn't want to show the exported code yet, but think of this data here in the context as just a JavaScript object, just a JSON object here, as a position that initiates with 0 and 0. And then you have the mechanics for updating this based on the state you're in or the events you're receiving. It's just the data that we remember. Does that make sense? And it has nothing to do with React context.
Okay, yeah, that makes sense now.
Right.
All right, cool.
Okay, so in terms of remembering the position, what should we do?
So we've got the position, which is just a tuple of X and Y. I think we can start with that and see how far we can go. I mean, we probably don't want to add too many things into context so we don't make it too complex, I think. Yeah.
But I think like when you're dragging, you need to remember the original position, right? Because later on, I'm just, trying to take a step ahead and see a step further in the future. What if later on, if you're dragging, you want to press escape and cancel it and get back to the original place? Like you don't want to drag. Like suddenly I decide, you know what, not worth it. Escape it. And then I want to get back. So probably I need to remember the original position and then also keep track of the diff. like how far I'm going in terms of X and Y axis.
X and Y.
Uh,
Yeah, the
yeah.
offsets. Yeah, that makes sense. Yep.
So let's call it original position, and then let's call it diff, which is exactly the same tuple. But then, yeah, let's add this to the context and then remove this from the context. Great. So we only have two things in the context right now: the original position, where before we start dragging, and the diff in terms of X and Y and how far we go through those axes. Great. So I think when you're idle, you don't have to do anything. When you receive pointer down, when you start pressing and you go to the pre-dragging state, that's where you need to query the original position of this element from DOM. Like,
Correct.
I'm starting here. If I start dragging, know that I was here. So in the world of a state machine, for executing effects, you might have wondered, where are effects? Where are things actually getting executed? So effects are sort of the cherry on top when you model with state machines. Like, state machines have figured out different ways of modeling effects. Like, effects could be synchronous, could be asynchronous, could be implemented in different ways. In XState, in a state charts, in a stately studio, let's just narrow the scope. In this application here, if you want to remember the position that's in the context, you have to have an action of type assignment. Assign action basically means give me the update and I will update something in the context. That's all. So there is no mutation, by the way, happening here. You need to give it a new value and it will update the data that you want to be updated inside the context of the machine. So you don't deal with this object in the context yourself. You don't say, hey, context.original position.x, change it to this. That mutation is not possible here. We need to, you need to tell the state machine of how to immutably update this through the assign actions.
Awesome.
And you add
So
an
as a naive React developer, I guess, does that sound similar to like set state or something like that?
Exactly. And the whole idea of having set the state and not mutating a state directly in React is React needs to understand where state is being updated so it can do certain things with it. That's the same idea here. Like, we need to know in what effects you want to update certain things in context, or what effects need to just be fire and forget and do some external stuff. Like, there should be a difference between an effect that just talks to an external server, like sends analytics or sends logs to Sentry or something like that, and an effect that is just for the sole purpose of updating a data. We have different types of events, and this is just a limited list of effects that we can have inside the state chart, like inside XState specifically. The XState library itself has like twice or thrice of this. Yeah, but like, so far in the studio, these are the most important effects that you can have in terms of actions. Anyway, let's just not talk about, I don't want to branch too much and overwhelm people. If you want to update original position, you need to add an assignment, which is exactly like set state, as Sage said. Thank you for that. You basically tell the studio that I want to update original position. And here's the beauty of these action values here, like these assignment values. They can be a static value. It can be like 2 and 3. I can update it to a constant value myself, or I can tell it to update it based on the current context and the received event. So the received event from DOM, which is the pointer down event.
Pointer down. Okay.
Yeah, it's sort of like the callback version of set state. So I can tell it that this is an expression, basically a callback. Like, we're working on a newer update to Stately Studio that takes, like, currently the way that you need to represent these JavaScript expressions is a little ugly, is a little too tight and little here. We are working on that to improve this, and we're calling those sources or implementations. That's the code name of the project, and that's going to be released very soon to improve this whole experience. For updating the value of original position, you can pass a function based on the current context and the received event. And this event is the one that is coming from the DOM, the pointer event. If you imagine sending the data from DOM, like do get bound in client rect and get the client X and client Y and send it through the event, those are going to be present on the event object here.
I see.
So all I want to do is tell it to basically update original position to, let's call it event.x and event.y.
Okay.
So we only send x and y as the payload of the event from DOM, and that basically does the job for us. So we remember the original position when this action is executed. So when you press your mouse, go to pre-dragging, on entry, immediately when you enter this state, your state chart will execute this assignment and update the original position based on what you receive from DOM.
Okay.
Yeah, and the same idea stands for pointer move. When you're moving, you no longer update original position, but update the diff. And that diff is also provided by the DOM event. So pointer move needs to send new x and y's from DOM, and
Yeah.
we update that in the diff in the context. So we can basically copy and paste this here. Okay, I need to allow pasting. Great. Let me just do an auto layout again. All right, great. But this time I want to modify this. So instead of original position, I receive x and y through the DOM event, and I add that to the diff. And I want to do the exact same thing again for dragging when I receive pointer move, because as long as I receive pointer move, I want to update the diff. Now, based on this diff, we will render the new position of that draggable handle in the UI. So imagine the width, and it's going to be position absolute probably, and then we want to set x and y, and then based on the diff that we receive here and the original position. So if the diff says I went minus 10 pixels, which is basically 10 pixels to the left, we want to say the left position in the style of the element is going to be original position.x plus diff.x, which goes this way and that way. Yeah. And then when do we want to commit this change? When you go from dragging to idle again. And I realized that we haven't modeled that commitment yet. Like, how do we commit this moving, this dragging? So if you're dragging and then you stop, pointer up, we want to commit this new position. So the pointer up is here. We want to add an assignment action again. Actually, I don't think this should be assignment anymore. Actually, we want to do that. We want to nullify diff again. This is where we get to updating the position. So we want to reset diff, and we probably want to reset original position as well. Great. But we also have to update the position of the element as well, right? Or maybe, actually, we don't have to, because we were rendering.
Yeah, we don't have to. Yeah, we rendered. Yeah, correct.
Yeah. But if you were modeling with DOM, then you had to actually like have another action that updates the DOM. Yeah, and I'm assuming.
So I've got one question here. Sure, I mean, I see that like for the pointer up in the actions, we've got like we're resetting the original position back to 0. Does that mean like we literally lose the position? Like we literally lose the position of the element, or it seems to me like maybe we probably don't need to reset the original position, so at least it stays where we
actually put it. You're absolutely right. See, this is the point of modeling with diagrams. Like, you're watching this stream and you're correcting my mistakes. And believe me, like, I mean, you've done development yourself, so you understand like how hard this could be to trace back again in the code.
Yeah,
like when you're figuring out like where things are going wrong. But like, this is easy. And another aspect, like before we move to the code, I think this is good enough for modeling with code right now. We have the happy path at least. We haven't yet modeled the cancellation and stuff, but we'll get to that later. One little nifty trick here with the state machines is that you can simulate the logic that you diagram. So you can say opening the panel is like, oh, okay, so I clicked on the button. And then what happens if I like press somewhere, press down, like, oh, okay, I go to pre-dragging and this action will be executed. So if I start moving, I go to dragging, I move. I'm clicking now. I keep moving, and then I do pointer up and I get back to idle. That's great. And I close the panel. Now, what happens if I'm dragging and I just accidentally somehow close the panel? Like open the panel, pointer down, pointer move, same drill. I'm dragging here, and then for some magical reason, the panel is closed. And you don't have to do any sort of cleanup as long as you model everything in the
Mm.
diagram here. XState in the runtime will take care of the exported code and clean up and everything like that. So your state works, everything resets, and you don't have to
Awesome.
reset dragging just because you went to closed. I'll stop
Yeah, that's
talking.
awesome.
I talked too much. Sorry about that.
No, that's awesome. Actually, I love this. I was going to just bring in one perspective. So in my mind, when I saw you model this, I mean, I actually smiled and I was so excited because, I mean, we haven't gotten into VS Code at this point, but it feels like most of the code is just there. Like, I mean, the diagram is the
Yeah,
code pretty much, and like, you just click on a code button, and then all of a sudden we see this XState code that's pretty much ready for us to go and actually like just write implementation details for all of these different events, which is exciting. Now, the twist that I want to add to this is, I mean, in the diagram we had in Figma, I don't know if you
mhm.
want. Can you open the Figma
Oh yeah,
document?
there you
Yeah,
go.
we've got this like other handle called resize handle, right?
Yeah,
Um, then I'm thinking that like, I mean, while I'm thinking through this, I want them to make sure that like the events from the resize handle don't sort of like cause unintended like side effects in the open state, because I'm still technically in the open state, but this is a different like mode in the open state where I'm not
mhm,
dragging this time, but this time I'm actually resizing. So how do we
yeah.
differentiate between these two types of events, so that like I don't start to resize and my panel is moving at the same time, which is so weird.
Yeah, that's actually a really great point because it might show that the model is wrong or too abstract that makes a collision between these two, like brings conflict, but actually not. Like this is the place that your implementation needs to sort of narrow the origin of the event and like have you can have like a conditional basically in your diagram here to say if the event was originated from the resize handle, go into the resizing state. Otherwise,
Mm,
keep moving to the dragging state. Like I can show you like quickly here, and then we can pursue this idea. This is actually an
yeah, sure.
absolutely great question. So when you're idle and you receive a pointer down, you go to pre-dragging. But this is naive because, as you said, this is not taking into account that this might actually come from resize handle, which the purpose would be resizing, not dragging. So it would be really weird.
Yeah.
But here, you can put a conditional, you can put a guard here, and you can say if the event is coming from what's that drag handle? Was it the
Drag
name?
handle. Yes,
Yes,
correct.
yes, there you go. If the event is coming from drag handle, only if that event is coming from there, we go to pre-dragging, which means the purpose is dragging. And the implementation for this can be handled in the code, where we have a ref to
Mm,
the element, and we say, hey, the event is coming from there. And you can probably, I think we can check the current target or target. I keep forgetting
yeah.
which one is the right one. Yeah, on the event and understand where it's coming from. Or another way
Yeah.
would be to basically handle all pointer downs to pre-dragging and stop propagating pointer down from inside the resize handle and handle it differently and send a different event.
Okay.
But yeah, but that means that you're putting some logic inside your
So
implementation.
my
You're
logic.
making it
Yeah,
too
sure.
aware. Exactly. So just for having like, for the sake of curiosity, we would have like a resizing state here. And if the pointer down comes from drag handle, it goes there. Otherwise, we add another transition. Let me just make it a little bit more clear. Otherwise, you can have branching that this event will take you to resizing state. That's
Mm,
all you need, basically, to handle the conflict. Only a single condition.
nice.
But this time, the condition is inside the state machine. So this means that you're not figuring out where things are branching. Everything happens inside this state machine.
Nice.
Great. So I think, would you be comfortable taking the implementation, like driving the implementation in Code Sandbox or somewhere, Sage? You like that?
Uh, yeah. So we actually like. I mean, we've actually spent like maybe 45 minutes already.
Oh, we did.
So
Wow,
what we
time
can do
flies.
is actually like we can do like another stream to actually like do the implementation of the styling,
Yeah,
so that we don't
yeah,
have to rush through that, because I really feel like we need to actually show people like, I mean, these diagrams are cool, the code is cool,
mm,
but I actually want to see this thing work, right? So we can definitely like go
exactly.
from that in a different episode to show them. But I think like where I really love to end is some sort of model around like the resizing, and maybe we could just finish up with the modeling, of like resizing, and then from the next episode we can go into the implementation.
Oh, sure. Yeah, yeah. Okay. So if the pointer down came from the drag handle, we handle the dragging scenario. The
Yeah.
scenario where we want to have the resizing is basically we would move to the resizing. So maybe it might help if I start refactoring these two states inside like a dragging state, but
Mm,
I don't know if that's necessary. Maybe we can just flatten it out for now.
okay.
Let's say that you're resizing. So what would happen? Could you describe resizing to me, please? Like I want to model based on your description. I want to get that requirement from you and try to model it.
Okay, so let me wear the hat of a product manager or a project manager right here. So let's go.
I'll move to
So
the Figma part.
yeah, so I've got this resize handle, and what I have to do there is to like pointer down the pointer down event. So it's pretty much I go there, I click on that, and then I start to drag. So for now, we're just gonna assume that the resize handle is always at the bottom right. We don't want to
Mhm.
undo too much logic, but you can always figure out how to make that dynamic. So bottom right, I click on it and I can resize the element. For a much more complex logic later down the line, we'll see you probably will be able to set a min and a max width so that you don't just like resize to zero. So most
Yeah,
likely we want to have some sort of guard in place to make sure that like we don't resize beyond a specific minimum and maximum, I think.
yeah. Or maybe like you, as you said, like the resize handle right now is at the bottom corner, but maybe it could be any of those four corners.
Any
Like
corners, right?
yeah, exactly, like an operating system window, like a floating window.
Yes.
Yeah, but let's start small. So resize handle is there, and what we want to do is when we are dragging this little pink square around, we want to keep remembering again the position. So while we remember the position and that diff, we also adjust. This time we don't adjust the top and left of this whole panel, but rather the width and the height.
And height, correct.
Exactly. All right. So I can also show you a little optimization later instead of having to render the width and remembering that on every pointer move. Like there's a little trick that David used before in one of our streams that helps optimizing what you need to remember in terms of memory and rendering, but like we'll get to that later. Right now, let's just assume that we want to remember the position. Again, when we're resizing, let's call this pre-resizing. And this is where, same drill, we want to, it's basically very similar behaviors between resizing and dragging. So you want to remember the original width and height, right? Maybe this time we call it original size.
Yep.
Yeah. And we get the W and H from event, from DOM. And I make sure that I add original size here. And this time we're gonna, it's still a tuple, because that's just perfect. Great. And maybe for the diff, we can reuse our diff property in the context, because dragging and resizing are not supposed to happen at the same time. So we don't need yet the fourth property in the context. That diff is enough. Then you have resizing. When you get, like when you receive pointer move, you start resizing, and instead of, yeah, basically we have pointer move here again. And I'm going to call this resizing. On pointer move, let me just copy this here. Accidentally zoomed the selection. And then we want to, we have pointer move again. Not that. Self transition. Try to be too clever for a moment. All right, then copy this and paste this, and that's it. And then you have pointer up. So this is where the conflict actually happens. Like when you try to abstract too much. Pointer up, we need to understand if this pointer up is coming after resizing or after dragging. If this is the finishing of the dragging or the end of the resizing. So instead of probably having one single pointer up here, maybe we can have two different pointer ups. So one could come from dragging to idle. That maybe not actually.
Maybe not. Yeah, that's what came to my mind, because the diff is pretty much the same idea.
Exactly.
So
Yeah.
Yep.
Yeah, You're right. You're absolutely right. We're resetting the diff in the context. It's not doing any sort of magic. So it can just stay there. Again, like having a diagram for the model, like helps you understand the breadths and the depths of the problem you're solving. So I can see everything at the same time. It's great. I don't have to scroll through lines of code and try to make sense out of
Yeah.
that.
So,
So it is
I'm
it.
going to
Like
introduce another twist to this, which is be like our final twist before we
you
end.
keep.
Before we end
It's
time.
funny. You keep saying that we're running out of time, and you keep adding more twists.
Yeah, I'm trying to give you like the feeling of like a classic open source project where you say like, this is my panel and it's done, and then someone goes to create a new issue to say I need this thing to be able to resize, and then another
Of
person
course.
goes to say I need to be able to dock these panels. Like I want to be able to sort of like while I'm moving it, I want to actually like dock it at some point. Can you please expose a property to help me do that? But now,
Mm,
like, I'm also trying to showcase the beauty of state charts in the sense that, like, I mean, as we're introducing this new requirement, all we had to do is just to draw some rectangles and copy paste a few things in there, and the logic is pretty much done. And without having to write any single line of code, like this logic, this diagram here is understandable by any engineer, and you can even find
exactly.
bugs just by looking at this
Exactly.
logic. Yeah. So I
Exactly.
wanted
You
to.
also you see like sorry for interrupting. I just want
Yeah,
to
yeah. Go
quickly
ahead.
say that you also see how similar certain behaviors are. Like dragging and resizing, pretty much the same thing.
Correct, correct. And I think like one of the things you ended up with is like the fact that we said, okay, for pointer up, maybe we just use the same thing. But now then it occurred to me that like, I mean, because we have this idea of docking the panels, where like when I drag it to let's say the far left and I release it, I want it to like actually just like I mean resize to fill that dock dimensions. So that means
Mm.
that the pointer up event is not technically the same between with the dragging and the resizing. What do you think?
I'm thinking you're correct. But like docking is one ending scenario of dragging already. So you know that you're dragging. Like but you don't know whether you end up dragging with some arbitrary position or you end up with docking into a panel.
Mm.
So that pointer up will come from dragging. Um, I think I think all we need to do is to send a property through the event payload saying that this pointer up is coming from a dock panel or not. And if it's
Oh, that makes
coming, then conditionally just try to execute the dock effect. That's all.
sense. Yeah, that makes sense. Yeah, that's awesome.
Yeah, sometimes like the implementation needs to handle a little bit of payload.
Sure,
Yeah.
sure. Awesome, awesome. Yeah, this is really amazing. Yeah, thank you so much for walking through this slightly interesting component. I'd say, and I think it's pretty much like a very useful feature for most apps these days, where you've got some sort
Yeah.
of panel. And I think the really cool part that I have to end with is the fact that a lot of this logic does not depend on any framework. It's pretty much JavaScript. You can use it like anywhere, React Native,
Yeah.
React on the web with Vue.js, Angular, whatever you want, and you can
Like
actually
that.
just like execute them. Look at this. This is awesome.
Exactly. Like Stately Studio gives you multiple formats to export this. I mean, this is just a never-ending basically list. We keep adding more export formats here. But you could actually go on and generate a React app just because
Oh wow, that's awesome.
yeah, we're a fan of React at Stately. We implemented Stately Studio using React. And yeah, we have a generate React app that will generate the whole boilerplate, like the setup of a React application based on your state machine for you. We even have open encode sandbox or stack blitz, which makes
Oh
it even
cool.
more productive because you don't have to copy paste code yourself. Like you have your state machine already in here, formatted
Nice.
and great and everything. Yeah, I mean like because the UI is generic, you need to go on and tweak what you're rendering, but like the state machine is there. One other thing is you don't have to always export to TypeScript or JavaScript. Like if you want to implement this in some view library in Rust, for example, you can take the JSON of the state machine, which gives you the whole logic. Even your like inline assignment expressions are here. All you need to do is to have an interpreter of the SCXML standard to interpret this,
Nice.
and that will just work. Or if you're trying to document this, like exporting to Mermaid with like the preview doesn't work because of a technical limitation of Mermaid library itself.
Mm.
Well, like
True.
Mermaid is here, and if you paste it anywhere, like the Mermaid playground, basically, or any document, like GitHub supports these out of the box. If you paste them there, or Confluence, they support Mermaid, or Markdown, even user stories, basically. So the whole idea is the diagram of your logic. It doesn't even matter if it's driven by a state machine or not, as long as you have a bunch of boxes and arrows connected to each other, representing logic and behavior. Just call some diagram a picture. You can use that as a single source of truth, and everything else just comes as one of the ways of implementing, or one of the ways of understanding this diagram. Even you
Awesome.
can take this, but this diagram just gives you the whole graph of your logic. So technically you can modify that graph, have some you know graph magic in place, and generate the tests based on your logic, because you
Nice.
have the logicals already. You figured out everything yourself. You just have to generate the logic based on the graph of generate the test based on the logic of the graph that you have. And Studio makes it really clear that what these tech specs are, and basically like what are the scenarios that they're trying to test. And you can export this test, and you can have different templates like Playwright, Cypress, whatever,
Oh wow,
and
that's
everything is
awesome.
work. Yeah,
Yeah,
maybe
that's
we
so nice.
can try to show off these later on in
Yeah,
other
yeah, yeah, for
series.
sure. So in the next episode, we're gonna delve right into the code, set up the React project, do some styling, and actually like get it into work. And then we'd actually be able to like see and enjoy the benefits of this beautiful state charts we created. Thank you so much for that. I know it's pretty late on your end. I mean, I'm sure your brain is fuzzy right now with all of the requirements I threw at you. Thank you for joining.
Thank you.
Really enjoyed the session.
Thank you for having me, Sage. I really enjoyed my time, and I can confirm that I was asleep throughout the whole stream. Just kidding, just kidding. Thank you everyone for watching, and thank you for your support. We definitely want to make a series out of this, because Sage is one of my most favorite people on the planet. So I'm gonna
Oh,
do this. I'm
thanks.
gonna make this work.
Yeah, thanks a lot for that. Thank you everyone for joining. We'll catch you all in the next episode.
Cheers.